Today we're on day 5, conversions from radians to degrees and degrees to radians. Here are the supplies you will need. So to convert from degrees to radians and radians to degrees, you need to know what a radian is. By definition, a radian is the measure of an angle when drawn as a central of a circle would intercept an arc whose length is equal to the radius of the circle. Long of the short, and in layman's terms, what this means is if you draw a regular circle with a center, you draw a radius of length r. You note that that length is r, and you draw the same length around the outside of the circle so that you have an arc on the outside of the circle that is the exact same length as your radius. In other words, of length r. Draw a second radius to the other edge of that arc, and you have an angle whose measure is equal to 1 radian. Thus we can see that the measure of an angle in radians is going to be equal to the length of the arc over the length of the radius. How do we know the mathematical value of a radian? Well, what we can do is utilize a formula from geometry, c equals 2 pi r. This is the circumference formula which you may remember from geometry, and this tells us that the length around the circle is equal to 2 pi r. Well, we also know that the length around a circle in degrees is 360 degrees. So we substitute that in for c and call it equal to 2 pi r. Next, we can divide that 2 pi from both sides in order to get the length of the radius alone. The 2 pi on the right side will cancel out, and the 2 and the 360 will reduce, so that you're left with 180 degrees over pi is equal to r. What we noted from the last slide is that r is equal to the length of 1 radian, or the measure of 1 radian. Thus we see that 1 radian is equal to 180 divided by pi. So to change from radians to degrees, what you're going to do is take the radians that you're given and multiply the radians by 180 degrees divided by pi. Next, you're going to reduce the fraction that results. A slight hint to reduce intimidation: the pi will always reduce, and you'll see what I mean in our examples. Here we're asked to find the degree measure of an angle given the radian measure. The radian measure here is pi over 4. So I'm going to start by rewriting my pi over 4 and then multiplying by the conversion factor, 180 divided by pi. What you notice is that pi cancels out in the numerator and the denominator, and I'm left with a fraction of 180 over 4, or 180 divided by 4. I plug this into the calculator, and I get a value of 45 degrees. Note the degree sign because we are now in degrees. This should always be included. Here we're asked to find the degree measure of an angle given the radian measure and then sketch. Well, we're going to do the same thing we did in the last example. Start by writing the fraction we're given, and then multiply by the conversion factor, 180 divided by pi. You notice that pi cancels out once again, and we are left with a new fraction equivalent to 2 times 180 all over 5. If you plug this into your calculator, you should get a value of 72 degrees. Now we're asked to sketch. Well, first we're going to sketch our x and our y axes, like so. And then I'm going to sketch my initial side. The question is, where does 72 degrees lie? Well, we know that each quadrant has 90 degrees. X on the right has a 0 degree mark, y has 90, and each subsequent line has 90 degrees extra. Here, we know that 72 degrees will lie between 0 and 90 degrees, so we sketch the terminating side and we label the angle 72 degrees. In example 3, we have 5.8 pi. Well, first, I'm going to make sure that I place that over 1, and then once again multiply by my conversion factor of 180 divided by pi. The pi's cancel out once again, and I'm left with a fraction 5.8 times 180 all over 1. If I plug this into the calculator, I should get a number resulting in 1044 degrees. I once again am asked to sketch. So I'm going to draw my axes like this and label my initial side. I know that I have a number that is greater than 360, so I'm going to start with one spiral. That spiral is one time around, or 360 degrees. Not quite at 1044, so I'm going to go around in a circle one more time. That's my second spiral. I add that to the 360 I already went. That means I've traveled 720 degrees. I'm getting close. I want to see how close, so I subtract that 720 from the 1044. I realize I have 324 degrees left to go. What quadrant will 324 lie in? Well, I know this bottom arrow represents 270 degrees, so 324 will lie between 270 and 360, placing it in the fourth quadrant. I'm going to sketch my terminating side, like so, and then place an arrow at the end of both my terminating side and my spiral. At this point, my sketch is complete. In example 4, we are asked to find to the nearest minute the measure of the angle, and we're given it in radians. So start by writing your 3.45 and placing it over 1. Multiply this by your conversion factor, 180 divided by pi. You should come out to a new fraction, if you plug this into your calculator, of 621 over pi. Now I know what you're saying at this point. The pi is supposed to cancel out. The pi is supposed to cancel out. Don't worry. Trust me, go along. We want to find this to the nearest minute, which means we're going to have to use our DMS mode. But to use our DMS mode, we're going to need a decimal answer. So first, plug into your calculator 621 divided by the measure of pi. To get pi, you hit second and this button above here that's shown on the calculator. Hit enter and you should get a decimal value of 197, etc. Hit second apps and use your DMS mode, and this will give you your degrees, your minutes, and your seconds. If you round to the nearest minute, you should come out to 197 degrees, 40 minutes. When changing from degrees to radians, you're using the reciprocal that you would from radians to degrees. Multiply the degrees by pi over 180 and then reduce the resulting fraction. The resultant fraction will have a pi included with it. Now what you should note is that you do not have to estimate the value of pi, but can leave the answer in terms of pi. We'll see what this means in terms of our examples. In these two examples, I'm asked to find the radian measure of the angle given the degree measure. Note that both of the examples are in degrees. So what I'm going to do, I'm going to start with example number 5. I have 75 degrees, which is a whole number, so I place it over 1. I multiply by the new conversion factor, pi over 180, and I say to myself, I'm going to rewrite this. Because multiplication is commutative, I can say that this can be rewritten as 75 over 180 times pi over 1. Now for now I'm going to leave this pi over 1 alone and focus on this new fraction 75 over 180. If I reduce this fraction, I end up with 5 over 12. I'm still going to end up multiplying this fraction to the pi over 1, which means that pi is going to end up in my numerator. I extend that bar and I say that my answer is now 5 pi over 12. And I'm done. You're saying, well, what about pi? It's 3.14. Leave it in terms of pi. You don't have to estimate. You don't have to use 3.14. You don't have to have any decimals. Your answer can be left in terms of pi, 5 times pi over 12. In example 6, we're going to do the exact same thing. Place 315 over 1. Multiply by your new conversion factor, pi over 180. Rewrite it so that your two numbers are a new fraction, 315 over 180, and you're multiplying by that pi over 1, or in this case, just pi. Focus on your new fraction, 315 over 180. How do I reduce this? Well, you can put it in your calculator, or if you have good mental math skills, you can reduce this down to 7 over 4. Once again, multiply by pi in the numerator, and ta-da! You're finished. 7 pi over 4. It's that easy. So example 7, we got to dig back to algebra. We're asked to find the exact value of a function f of x equal to 4 sine x over 3 plus sine of x, and we're given f of pi. We want to find that value at f of pi. Remember to algebra 1, when you're given an f of some value, you plug in that value for the given variable. In this case, plug in pi for x. So I'm going to rewrite my function. F of pi is equal to 4 times the sine of parentheses, pi over 3, because I'm substituting that pi in for x, plus the sine of pi, because I'm once again substituting pi in for any x that appears. Now, to get an exact value for this, I need to have this in terms of degrees. I can't solve it with the radian measures that are here, so I'm going to have to convert them to degrees. In other words, I need degrees to solve, not college degrees. Moving on. Pi over 3. Let's convert this from radians to degrees. I multiply pi over 3 by my conversion factor, 180 times pi, or over pi. The pi's cancel out, and I'm left with 180 over 3, or if you plug that into your calculator, you get a value of 60 degrees. I draw my little box to keep things a little bit organized. And now I'm going to convert that pi into degrees. Well, it's not a fraction, so I'm going to place it over 1. Assume that it's a whole number. Multiply by my conversion factor, because I'm going from radians to degrees. 180 over pi. The pi's end up canceling each other out. I get 180 over 1, or just 180 degrees. Beautiful, isn't it? Now, I'm going to take these values and plug them back in for the radian measures that I just converted them from. So I should have a function equal to 4 times the sine of 60 degrees plus the sine of 180 degrees. Now think back to day 3, just a couple of days ago. You should know that the sine of 60 is equal to radical 3 over 2. Beautiful. And the 4 stays along. I add that to the sine of 180, which you should know also from day 3 is 0. Well, all that's left now is to multiply that 4 to the radical 3 over 2. If I do this correctly, you should get 4 times radical 3 over 2. The 4 and the 2 reduce out to 2 over 1, which means I should be left with the fraction 2 radical 3 over 1, or just plain 2 radical 3. So here's what you should be able to do. I hope that this has been informative. Make sure that you're going back and checking if you have misconceptions. And once again, this is Mr. Mackman signing off. Have a lovely day.